Ladies and gentlemen, welcome to the beginning of 3-4. We are looking at starting to prove that triangles are congruent. So we have to come up with a proof. The most simple way that I do it is with a two-column proof. So basically, you need to explain why things are congruent. Okay, so let's back up here. Let's talk about 3 for a little bit. So when I look at this, what ways do we have to prove that our triangles are congruent? So if I look here, STU is congruent to W or VWX. So S matches up with V. Okay, T would match up with X, and U would match up with W. So STU matches up with VXW. That reason would be side, side, side postulate. Okay, a postulate is basically like a reason. So here, CDE, C would match up to F. D would match up to G, because they're both the right angles. E would match up then to H. So here I've got the angle in between two sides, okay? The two sides that are congruent help create the angle. So that's going to be side, angle, side. So that's going to be that reason. So here, STV, S will match up with U. T here will not actually match up with the other T. T will match up with V. And V, this V, actually matches up with that T. And that's going to be angle, side, angle. So this last one here, oops, WXY, W is going to match up to A, X is going to match up to Z, Y is going to match up to itself. And here's kind of why I can say this. Those two angles are vertical, so they're going to be congruent. So that's going to be angle, angle, side. Now the big difference between this one and angle, side, angle is that for angle, angle, side, you follow it around the triangle and it's the next side. So if I start at W, that's one angle, next side. From A, it'd be one angle, next side. So it's the next side going around the triangle. Okay, so hopefully that kind of clears some things up. So now, how do proofs work? Okay, so here's kind of an example of a proof. And let's just kind of look at how they do it. So here's all they do. You start with your given statements. That is the very first thing you begin with. Okay, so N is the midpoint of LW. N is the midpoint of SK. So you're looking at, stop doing that, go back to that. Sorry, broke that. Stop doing that. So I'll go back to that. Boom, boom, good. So here, start with your given. So then the next thing they do is, because they said midpoint, midpoint has a special meaning. Midpoint means it cuts it in half. So I can say, you know what, because N is the midpoint of LW, I can say that's congruent to that by definition of midpoint. I can also say that is congruent to that by definition of midpoint. And I could have easily split this into two statements, but they just say it in one, so that's fine. Then they say LNS is congruent to WNK. Those two angles are congruent. Why? Because vertical angles are always congruent. So now for my triangle, it's side, angle, side. Okay, so take a look here. What are we trying to prove? You're trying to show that LNS is congruent to WNK. Whatever you're trying to prove needs to be your last statement. And your reason for triangles better be one of those reasons that we talked about on the previous page. So side, 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 angle, side, angle, side, angle, 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 side. So let's take a look at this one. So you're given these two statements, so they threw that in the same statement. So now look, what does that give you? Okay, so S is congruent to U. That's nice. Boom, Boom, I'm going to mark that up here on my triangle, on my two triangles. SP is parallel to OU. They're given that. So what does it mean to be parallel? Well, if I've got two lines that are parallel, what kind of angles are those? Those are alternate interior angles. So those are going to be congruent. That's kind of what they did here. They said SPO, and UOP are going to be congruent by alternate interior angle theorem. All that stuff from Unit 2 that comes flooding back, that's all going to be true in parallel lines. Then they say OP is congruent to OP. You're congruent to yourself. That's called the reflexive property. That means that you're part of both triangles. You're equal to itself. This is going to be used a lot anytime that they share a side or share an angle. You get to use this. So, share a side or angle. Reflexive. Reflexive means that you're equal to yourself. So now, looking at the triangle, I've got one angle, two angles, next side, one angle, two angle, next side. That's going to be angle, angle, side. Okay, so that's what a proof looks like. Start with your given statements. So, if I look here, what are my given statements? Well, PQ is congruent to RS. That's given. And that's marked for me. Second statement, PQS. Back up. PQS congruent to RSQ. Given. So they mark those for me right there and right there. So now I've got the beginnings of one side and one angle. I'm looking for either another angle or another side. But if I look, QS is part of both triangles. So I can say QS is congruent to QS. You're equal to yourself. That's that reflexive property. Reflexive, not reflective. We're not talking about a mirror. Okay, reflexive means that you are congruent to yourself. So now if I look, what kind of situation what do I have here? Well, I have a side, I have an angle and a side, angle, side. So I'm going to have a side, angle, side postulate for an answer. So if I look, let's take a look here. This one, pretty straightforward. AB to DE is my first statement, and that's given. Now I'm going to say AC congruent to DF. That's also given. BC congruent to EF. That's also given. This one's a gift. I mean, really. This one, prove triangle ABD congruent to triangle DEF. By all the given information, yeah, they're congruent. They're side, side, side congruent. So it's really nice. That's a very, very easy one. You're not going to see ones like that. So just realize that that's kind of a gift one. So let's start taking a look at ones that are slightly more different, slightly more difficult. So, why do I know this? Well, given. Then I see AB parallel to DE. So now parallel tells me some things. Bisect tells me some things. AE bisects BD. So BD gets bisected. Bisected literally means cut in half. So I go boom and boom. So why is BC congruent to DC? Well, that's going to be by definition of bisector. So now, why is ACB congruent to DCB? What kind of angles are those? Those look like vertical angles to me. So those are vertical angles. So now, because these two are parallel over here, parallel here, I can say this guy is congruent to this guy because of alternate interior angle. So kind of drawing it a different way, if I go right here, that one's going to be congruent to that one because they're alternate interior angles. So I'm going to say angle B congruent to angle D. So now my last statement is what I'm trying to prove. Triangle ABC congruent to triangle DCE. So I've got to look at if they tell me things are parallel, that tells me some things. If they tell me things are bisecting, that tells me some things. So I've got to be on the lookout for kind of what they give me. So now this one doesn't give you anything to start, so we're kind of building from scratch here. So the first thing I want to do is draw a T, and I start with my given statement. PR congruent to TR, and angle P congruent to angle T, given. So that's my given statement. So now what else can I glean from this picture, this situation? Well, I know that these two are always going to be congruent no matter what because they're vertical. So I can say angle PRQ is congruent to angle TRS. Why? They're vertical angles. So that's enough to say, oh, by the way, these triangles are congruent by angle, side, angle. Angle, side, angle. That's all I'm looking for. All right, so let's take a look at this guy. So what do they tell me? They tell me C is a midpoint. Great, C is a midpoint. So that's going to be my first statement. C is midpoint of AE. I really hope your handwriting is way better than mine. So let's talk next. They know, and they also tell you BA is congruent to DE. They tell you a lot of stuff. And they also tell you angle A is congruent to angle E. So they tell you BA is congruent to DE. They tell you that, tell you that, tell you that, tell you that. What does it mean to be a midpoint? Well, if you're a midpoint, that means you cut something directly in half. So I'm going to say AC is congruent to EC by definition of midpoint. Then, by that, I know ABC congruent to EDC by angle, or side, angle, side. There's my answer. All right, so play around with this. Start with what you're given. Look at what information they give you and see what you're doing. All right, come talk to me with questions.